Hi, I'm Derek Downey, a developer advocate for Google Cloud. I am currently working on developing a banking application that leverages Cloud Spanner, the highly scalable managed relational database from Google Cloud. In the previous video, I set up a regional Spanner instance with a small amount of compute capacity for developing my banking application. I also created a customers database on the instance, and all the tables related to my app will live in this database. Now, my company might have other internal only data completely unrelated to my banking app. That data could be placed in a separate database because Spanner instances can have multiple databases. Databases are a way to organize related tables together and to provide additional access control to the data stored on the instance. For example, my banking app should definitely not have access to the internal database. Besides access control, each database can be configured with different options that affect the performance, recovery, and security of your database. These options control the optimizer version, version retention period, and database encryption. The first database option is the optimizer version. The optimizer's job is to create an execution plan that is an efficient way to retrieve data from Spanner based on the given SQL query. It has a direct impact on performance of requests issued to your database. Over time, the query optimizer will change to improve the accuracy of the estimates required to create this execution plan. When Spanner releases a new optimizer version, the default behavior is for databases to use the new version 30 days after release. Optimizer versions can change the performance of your query workload, so it's important to compare query performance of the new version with the older version. You can pin the optimizer version a database uses to a specific version by altering the database. Altering the database optimizer version to null resets to the default behavior of updating 30 days after the release of a new version. You can also change the optimizer version for individual queries by providing the optimizer version query hint. This is useful to validate queries where stable performance is critical without changing the optimizer version for the entire database. Another important database option is the version retention period, which affects the ability to perform a point-in-time recovery. By default, Spanner will maintain all versions of the data and schema for 1 hour. In my banking application, I want to protect against accidental data loss. With Spanner's default retention, I have an hour to copy the data as it existed before an accidental change, and then load it back into the database. During normal business operations, this hour might be enough. But what about during off hours or the weekend? I might not be able to respond in time to avoid data loss. So I want to be sure to size my version retention period to give my team enough time to recover outside of normal hours. One way to do this would be to set the version retention period according to my backup frequency. For instance, if I take a backup of my database once a day, then I will want to set my version retention period to 1 day. The last option I will cover is how encryption is handled for Spanner databases. All data in Spanner is encrypted at rest. By default, this encryption is handled for you by Google Cloud. However, if you have specific compliance or regulatory requirements on the keys encrypting the data, Spanner offers the ability to deploy your own encryption keys. These are called customer managed encryption keys and are managed through Google Cloud KMS. It is possible to have some databases configured with customer encryption keys, while other databases on the same instance use Google Cloud to manage encryption. Setting up and managing these custom encryption keys is beyond the scope of this video, but there are some important pieces of information when using custom encryption keys. First, a database must be created with a custom encryption key. Custom encryption keys cannot be enabled on an existing database. Second, for backups, the primary version of the encryption key at the time of backup creation is used to encrypt backups. Finally, encryption keys must be available to decrypt the database and backups. If a key is deleted and can't be recovered, any Spanner database or backup encrypted with that key is unrecoverable. For now, I will be using the default encryption managed by Google Cloud for my banking application. Cloud Spanner offers the ability to organize related data into multiple databases on your Spanner instance. This provides some additional control over who has access to the data stored there. In this video, I went over some other options that give you more control over the performance, recovery, and security of your Spanner database. In our next video, I will go into more detail about the Spanner schema, including data types, data organization, and schema management. In the meantime, please let us know in the comments if you have any questions around database-specific options in Spanner.